What's going on, everybody? Welcome to the image processing with Python. So in this video, we'll discuss histogram stretching. So let me first tell you what is the difference between histogram equalization and histogram stretching. So both equalization and stretching are image enhancement techniques. Contrast stretching or histogram stretching is a linear normalization that stretches an arbitrary level of intensity of an image and fits the interval to another arbitrary interval, generally into 0 to 255. While equalization spread the most frequent intensity values. I have explained about equalization in details. So if you haven't watched that video, please watch it. It will be easy to understand stretching if you have some ideas about histogram and its equalization. Let's first see the example and then we'll try to implement it through code. Here we have 4x4 image with total 8 gray levels 0 to 7. And we have column for frequency of pixel for each gray value. So here you can observe that there are total 0 pixel for 0 and 7 gray value. So I'll put 0 in both cases. Now the gray value 1 has some pixel 4 in this case. So we'll write 1 in this column and we'll repeat same process for every gray level. Now let's see the formula. So Lmax and Lmin represent the maximum and the minimum of gray values. So it's 7 and 0 in this case. So 7 minus 0 will be 7. Now mmax is maximum value of non-zero pixels, means maximum value in this array, and it is 6 and the minimum is 0. So here we'll get 5 and L minimum is 0, so it doesn't matter if you add or not. Now we'll calculate values by replacing m with 0 to 7 and the pixel can't be negative, so we'll replace it with 0, and same for the 7, we are getting 8.2 but the maximum pixel value is 7, so we'll replace it with 7. Now simply round the values. So this column is final pixel value and this is initial. Finally replace the initial pixels to the final, means replace 6 to 7 and 5 to 6. Same for all. Now same thing we'll implement in code. So let's open your IDE. Now first thing to do is importing all the necessary libraries. Now read the image which you want to enhance. As I said earlier, stretching is enhancement technique. Okay, due to high resolution, we need to resize the image. So here I am resizing it to 800 cross 600 pixels. And I am also finding the shape which will be used later to generalize the code. Now we have to convert RGB image to binary image. So use convert color method for that. Now let's also manipulate the contrast and the brightness of the image. Here I am increasing the contrast value by alpha and also brightening the image with beta. So why we have brightened up the image, I'll discuss it later. So let's quickly visualize the image. So you can see that there are more white pixels and less black pixel due to increase in brightness. Also, plot the histogram of this image. So for histogram, I am not using the inbuilt function. I have implemented it in the first video of this series. So I am using that function here, and here I am calling that function which is hist. Now simply plot and see the histogram using plot and show command. So it is clear that there are more white pixels in the image, and in starting we have 0 black pixels. So we want to stretch this pixel from the spike to 0 side. So that's why I brighten up the image to make black pixel 0, so you can see stretching clearly. Now let's implement the main part. I will try to explain the code by comparing it with example. In this example, the first column represents the gray values which are 0 to 7. In our case, it's 0 to 255. While second column represents the histogram of the example. So here we have stored the histogram in X and we have reshaped the histogram to 1 cross 256. This third column we have discussed already. So here Lmax and Lminimum are 7 and 0 respectively in this example. So 7 minus 0 will be 7, so we'll put 7 here, but for image we will write 255. And as I said earlier, mmax and mminimum is 6 and 1 in this example. So to find that value in our case, we'll find maximum and minimum value of non-zero Y array. And if and also Don't forget to round the values using round method from Numpy. More than 255, we'll keep it as 255. And finally, we'll replace all the 1s to 0, all the 2s to 1, and same for all the gray value pixels. And our image is 2D, means we'll definitely need two for loop, one for row and one for column. So let's write it in general form using as. So that's why we did find a shape of the image previously. So read the values from pixel, we'll store it in any variable and change that value to final value from stretch variable. Now let's quickly visualize the image. So first plot the histogram of the final image and visualize the enhanced image. Okay, plot the histogram of the original image too so that we can compare it. And also let's see the original image. Okay, now run the code. So here in the plot, the blue color represents the previous histogram while red represents the new. You can also observe the clear difference here. The spike is moved ahead. Means in the next video, we will talk about spatial filtering. We'll implement mean, mode and median filter on the noisy image. And we are also making the same video for Matlab. So if you are not comfortable with Python, please go and watch the image processing with Matlab series. I'll put the link in the description too. Thank you.